Joint attention has been identified as a critical component of successful human-machine teams. Teaching robots to develop an awareness of human cues is an important first step towards attaining and maintaining joint attention. We present a joint attention estimator that creates many possible candidates for joint attention and chooses the most likely object based on the human teammate's hand cues. In order to process within human interaction time, which we define as less than 3 seconds, we start with a list of object candidates provided by the YOLO object detector. When using this with a low threshold, YOLO provides a number of possible objects. We use joint attention from the human teammate to reduce this to a reasonable bounding box. We use the wrist locations provided by OpenPose to provide a region of interest. Boxes within this region of interest are combined using non-maxima suppression. This provides the robot with the best guess of the object candidate at a time when a verbal cue is provided. We have evaluated this in our testing environment, which consists of a table with a cluttered background in a laboratory setting. 8 to 12 tools were scattered across the table during testing. A human identified each of the 10 objects to the robot by either holding a tool up for the robot or providing a two-handed gesture to the object. In both cases, the human labeled the object, i.e., this is a screwdriver, as a cue for the robot to engage in joint attention. The system was able to correctly create a bounding box for 85% of the objects that the human identified for joint attention. Critically, identifying each object was very fast and clearly within interaction speed. Across all 20 trials, it took an average of less than 3 seconds to request joint attention, process speech, and create the best bounding box. Our joint attention estimator provides a meaningful step towards ensuring robots enable human social skills for successful human-machine teaming. Critically important is that our approach is also fast enough to be useful for human interaction. We are currently working on other methods such as gaze, pointing, or single-handed holding to expand our interaction options.